Okay, we're going to look at using the upper and lower bounds tests for polynomials so we can reduce the list of possible zeros. So if we have a graph and we have points on our graph, we would have a point here which would be A and a point here which would be B. So this point A, this would be our lower bound, and our point B would be our upper bound. So it means that we limit the interval, so all the possible roots would fall within A and B. So the key concept is when we actually use the synthetic division and we get to our last row, our C value, so if our C value is less than equal to 0 and we're dividing, so that means we're dividing by a negative, so dividing by a negative, so let's use an example. So say we were dividing by -3 and our final row gave us something like 4 minus 6 plus 8 minus 10, 12. We would have a positive, a negative, a positive, a negative, a positive. So they're alternating. So if they're alternating, this will be a lower bound. So also, if our C is greater or equal to 0, so this is a positive, so for example we were dividing by 4 and we had our final answer as 4, 10, 24, say 90. Okay, so we've got non-negatives. This shows this is an upper bound. Okay, so there could be some larger, but there will not be any zeros at that point. Okay, so we have an example. So we're given the function, and if we look at this, we can see that we are expecting it to have 4 real roots. We have a coefficient of 2, and then we have a constant of -24. So the first thing we're going to do is use the rational zero theorem, and we're going to find the factors. So we're going to work out P divided by Q. So this is our Q value, and this is our P value. So the first thing we need to do is write all the factors of 24. So this is going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. And this is all divided by factors of Q, which would be plus or minus 1 and plus or minus 2. Now we need to write these out, all the possible combinations. So first of all, 1 divided by 2, so that's a half, so we could have plus or minus a half. Then we could have 1 divided by 1, so that would be 1. So we'd also have 3 divided by 1. We'd also have 3 divided by 2. So 3 divided by 2 is 1.5. So 2 divided by 1, we've got plus or minus 2. So we've got plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. So these are our possible answers. So now we need to test some limits. So if we were to graph this function, we would have something that is going to show us some zeros. So our zeros could be at minus 0.5 and 6. So our limits are going to be either side. So we're going to test our limits. So we think the intervals would be minus 1 and 7. So we're going to test our intervals. So this is our interval. So we're looking to not have a 0 remainder. So we're going to do synthetic division. So we're going to test first of all minus 1. So we're going to divide by minus 1, and we're going to bring down our values. So 2 multiplied by minus 1, minus 2, so minus 13. So this is be positive 13, 15, minus 15. And then minus 44 minus 15 is minus 59. So this is going to be positive 59. And positive 59 is going to be 35. So if we look at our values, we've got a positive, a negative, a positive, a negative, and a positive. And this is not a non-zero remainder. So we can see that minus 1 is not a root. And when it alternates, so when it alternates on the bottom row, this tells us that minus 1 is a lower bound. So now we're going to test 7. So testing 7, 2 minus 11, 2 minus 44, and minus 24. So bringing down the 2 7s are 14, 14 minus 11 is 3, 3 7s are 21, this is 23, and so 23 times 7 is going to be 161. 161 multiplied by 7 is 117. And 117 multiplied by 7 is 819. And this will be 795. So this is a non-zero remainder. So this is telling us that 7 is not a 0. So we need to check, and we can see that all our values are positive. So there's non-negative values. So 7 is an upper bound. Now we need to test the zeros. Now we believe the zeros at minus 0.5 and 6. So we need to test those. So first of all, minus 0.5 or minus a half. and we're going to use the values 2, minus 11, 2, minus 44, and minus 24. So dividing, so 2 times a half, so this is going to be minus 1. So minus 11 minus 1 is minus 12. Minus 12 times minus a half is going to be positive 12 divided by 2, which is 6. So this is going to be 8. 8 multiplied, so this is going to be minus 4, which is minus 48. Minus 48 multiplied by minus a half is going to be positive 48 divided by 2. So this is plus 24, which gives us a remainder of 0. The remainder of 0 tells us that minus a half is going to be a 0. So now we can use this. So this is our depressed polynomial, and we're going to test that 6, and we can use our values. So we're going to test that 6 is also, so bringing down a 2, 2 6s are 12, so minus 12, this is going to be 0, so 0 times 6 is 0, this is going to be 8, and 8 6s are 48, so we have a remainder of 0. So this tells us that 6 is a 0. So our conclusion, so the interval is at minus 1, 7, and our zeros are minus 0.5 and 6.